Section in Chapter 10 is titled Squares and Square Roots. So by the end of this lesson, you will be able to find perfect squares or square roots and also estimate square roots. So a perfect square is a number that is the square of an integer. And a square root is one of two equal factors of a number. The radical sign is what you see when you're asked to take the square root of a number, and the radicand is the value that's under the radical sign. Please make sure you have these definitions in your notes. So first I want you to just find the square roots. The first one is the square root of 9. And what you're asking yourself is, what's a number that you can multiply times itself to get 9? So what number times itself is 9? And hopefully you're saying 3, because 3 times 3 is 9. So that's finding the positive square root of 9. Example 2, you're seeing here we have the negative square root of 64. So we're still looking for the number that when you multiply it times itself is 64, but we want the negative of that value. So our answer here will be negative. And what number times itself is 64? Hopefully you're saying 8 times 8. So the answer to the negative square root of 64 is negative 8. Example 3, we have plus or minus the square root of 4. That means I want the positive and the negative answer. So you're asking yourself again, what times itself is 4? Hopefully you're saying 2, but we want the positive 2 and the negative 2. And since we want both answers, we put what's called that plus minus sign out in front. So example 1 was finding a positive square root. Example 2 was finding a negative square root. And example 3 was finding both the positive and the negative square root. Because remember, with negatives, if you take a negative 2 times a negative 2, you'll still get a positive 4. Some more examples here. For number 4, we have the square root of a negative 81. And this is very different from example 2 that had the negative on the outside. Now we have the negative on the inside. And this takes a little bit of thought to understand why the answer is what it is. But what you're asking yourself is there a number that when I multiply it times itself is a negative 81? So hopefully the number 9 is popping into your head, because 9 times 9 is 81. But if we have our answer as a positive 9, 9 times positive 9 is positive 81. And now if you look at it, maybe you're thinking, well, it's negative 9. But that same thing happens here. If you take a negative 9 times a negative 9, you still get a positive 81. So in fact, there is no number that you can multiply times itself to get a negative 81. So what do we write? That's the question. If you are asked to find the square root of a negative number, then we say no real solutions. And way down the line from here, when you get into Algebra 2, you start talking about what are called imaginary solutions. But for right now, we just need to understand that there is no real number that when you multiply it times itself gives you a negative 1. And now number 5 is different. Here the negative is on the outside, so we want the negative square root of 49. Well, the square root of 49 is 7, and we want the negative, or the opposite, so negative 7. Number 6, we have the positive and the negative square root of 16. So the square root of 16 is 4, so that's plus or minus 4. That's how that's read, plus or minus 4. That's the positive 4 and the negative 4 included in our answer. Now we're going to look at estimating square roots. So when integers are not perfect squares, you can actually estimate square roots mentally by using perfect squares. And we're also going to use a number line. So first I want you to estimate the square root to the nearest integer. So that's just to the nearest whole number. So we have the square root of 33. 33 is not a perfect square. So there are no two numbers that when you multiply them together, there's no number when you multiply it times itself will give you 33. But there are numbers that are close. So what we want to look at is what's a number that's a perfect square that's less than 33? And what's the closest perfect square that's greater than 33? Well, you can start thinking in your head 1 times 1, 2 times 2, 3 times 3, until you get close to 33. And hopefully you're recognizing that 5 times 5 is the square root of 25. That's a perfect square, and the answer is 5. And now we have on the other side of that 6 times 6. Well, that's the square root of 36 would be 6. So the square root of 33 falls somewhere between the square root of 25 and the square root of 36. Because it's closest to the square root of 36, notice it's 3 away versus 8. Then if we're estimating it to the nearest integer, we would say that the square root of 33 is about 6. Okay, it's not exactly 6, so make sure you're not using an equal sign, but it's about or close to 6. So let's estimate the square roots to the nearest integers. I'm actually going to start with number 8 using a number line. We have the square root of 60. So you have to be thinking about perfect squares greater than 60 and less than 60. So 1 times 1, 2 times 2, 3 times 3, until you get close to 60. Well, 8 times 8 is 64. So we have the square root of 64, which is just over the square root of 60, or just greater than the square root of 60. And you also have 7 times 7, which is 49, so the square root of 49, which is less than the square root of 60. You'll notice that the two numbers on either side will always be consecutive numbers, 7 and 8, 10 and 11, whatever they are. So again, we're estimating it to the nearest integer or the nearest whole number, and since 60 is closer to 64, we would say that the square root of 60 is about 8. And again, I'm not using the equal sign, I'm using the estimate or the about equal to symbol. It's basically an equal sign that's curled. So now if we go back up to number 7, the reason why I wanted you to skip number 7 for a moment is because we're talking about now the negative square root of 129. So these numbers are getting a little bit larger, but you may need a calculator to help you, and that's fine. So if you start doing like 1 times 1, 2 times 2, 3 times 3, until you get to something close to 129, most of you know 10 times 10 is 100. You may or may not know that 11 times 11 is 121. But again, here it's very important that we're paying close attention to that negative. We want the negative square root of 129. Well, 121 is very close, and that's negative 11. If we go on the other side of that to negative 12, that would be the negative square root of 144. And again, we want to plot that 129 right in about where it goes, estimating is it closer to 121 or closer to 144. Well, hopefully you're recognizing that it's closer to the negative square root of 121. So the negative square root of 129 is about equal to negative 11. Again, if there's a negative out in front of your square root, you need to have a negative answer. And let's try number 9. Number 9 is a little bit smaller, but we have the negative square root of 23. And hopefully you're thinking right now that 23 is very close to the square root of 25. So we have the negative square root of 25, which is negative 5. That's less than that. And then above that, we have negative square root of 16, which is negative 4. And which one is it closer to? Well, the negative square root of 23 closer to the negative square root of 25. So if we were to estimate the negative square root of 23, we would say it's about equal to negative 5. So today you were able to find square roots and also estimate square roots. And part of what I would like you to do in your notes today before you finish is I want you to find all of the squares from 1 to 20. So we're going to start with 1, 2, 3, 4, whoops, these should be squared, 5, 6, 7, 8, 9, 10, and I would like you to go all the way to 20. So you can do this finding with a calculator. You're just taking the number times itself, but this will help you with square roots if you know some of the perfect squares. I would like you to then do 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So please make sure you have all of those answers also in your notes. This will help you when we start the worksheet in class tomorrow.